All right, this is a video of the Radians activity. So, ancient Greek mathematicians noticed that the larger a circle's radius gets, the larger its circumference becomes. Here's a circle. How many times can the radius of the circle wrap around the outside of the circle? The solid orange arc shows what it looks like to wrap just one copy of the radius around the outside. Complete the sentence to show your guess. The radius fits around the outside of the circle blank times. You have to put your guess in here first to get the applet to work. So I'm guessing 6. That looks about 1/6 the way around. So there's one copy, 2, 3, almost halfway around. So actually halfway around is pi radians, or 3.141515. So the approximation for pi there, 4 radians, 5, 6 doesn't quite make it. But there are 2 pi radians in a circle. So next here, if I hit the play button here, I'm showing you that there's a little bit more than 6 radians. Or I could drag this here. The slider doesn't go anymore. But so 6 radians wasn't quite as good as the whole way around the circle. How many radians do you think is this the whole way around? The graph you made on the last page. So you might want to go back and put the slider all the way. We did that already, but just to see the relationship, the circumference, and this is going to be on other slides here. Let's make this bigger. Circumference is 2 pi r. Or 2 pi radians. A radian is the same length as a radius. So there are 2 pi radians in a circle. So this is another illustration of what's going on. So what's going on here is taking the length of a radius and wrapping it around the circle. There are 180 degrees in a half circle. There are pi radians in a half circle. This means that pi radians equal 180. Use this formula to figure out what 1 radian is. So 1 radian, we divide both sides by pi. And if I actually did that on the calculator, 180 divided by pi, so it's approximately 57.2 2958 degrees. Hopefully you got this formula, which we did. How many degrees on 2 radians? So it would be 2 times 180 divided by pi is about 114.6. Converting degrees to radians is easy. 1 radians, 180 pi degrees becomes pi over 180 radians equal 1 degree. How can we create the new formula? We can multiply both sides of the original formula by the reciprocal. Pi over 180. And we get the degree conversion formula there. Just like before, we multiply the number of degrees by pi over 180 to figure out the radians. So we use the formula to figure out how many radians are in 45. So it'll be 45 times pi over 180. And then just simplify 45 over 180. So 45 divides 45 once. So you have pi in the numerator and 4 in the denominator. So 45 simplified would be pi over 4. And then I want you to fill in this chart here. So in the degree column, you can have decimal values. In the radian column, I'd like you to leave the answer in terms of pi. So 3 times 180 over pi is 171.9. And then 250. So it'll be 250 pi over 180. And then simplify that fraction. 25 pi over 18. And if you're having problems simplifying, you can just do this. Over here on the calculator, 250 divided by 180, and then hit the fraction template there, and it's 25 over 18. Next one, 10. We're going to do 10 times 180 over pi. Is 572.9 or 573. And this one, 102 pi divided by 180. So you have to find what's the largest number that divides both 180 and 102. 102 divides both of those, so 51 pi over 90. And then 03 divides 51 and 90, so 17 pi over 30. And if I'm having problems, once again, I could just do 102 divided by 180 and then hit the fraction bar, 17 over 30. And then 2 pi, we know it's 360, but demonstrating it on the calculator, 2 pi times 180 over pi is 360 degrees exactly. And then the last one, 300 pi divided by 180. Well, 300 and 180 are divisible by 60, so you get 5 pi over 3. And write the formula for circumference. We did this already. Let's see, 2 pi r or and we know that there's 360 degrees in the circle. So we can say 360 equal 2 pi radians. And we can also say that 180 is equal to pi radians. So we already did this. It's 1 radian is wrapping the radius around the circle, one radius around the circle. It's a little bit more than 57 degrees. 13, we already talked about this, 360 is 2 pi radians. And let's see here. It's hard to be precise with this, but I was trying to illustrate that there's 3 pi radians and or pi radians in a half circle and 2 pi radians in the whole circle. And the same thing with this one. And that's here it says 5 pi radians would be 300 degrees, because pi radians is 180, so 5 times 180 divided by, whoop, that in parentheses, divided by 300. There's halfway around, like 3.14. When you go all the way around, it goes back to 0, so it's hard to see all the way around. This is pi radians. And then filling in this table, 90 would be 90 pi over 180. And that's equal to pi over 2. This one, 45 pi over 180 is pi over 4. 180 would be just pi. And 270 is 3 pi over 2. Negative 240. This probably illustrates how to do it.
Degrees and convert that to radians. So this is the same way as how would you do it in chemistry class. We need to get rid of that degree symbol right over there, which means we need to divide by degree. And since we want radian goes on top, and we know the conversion is 180 degrees is to pi radian, then we just simplify this fraction. And I do not want you to use calculator on this, make sure you reduce it by hand. So 135 and 180, 5 could go into both. So 135 divided by 5 is 27, 180 divided by 5 is 36, and we can further simplify it by taking out the 9. 36 divided by 9 is 4, so we end up on top 3 pi all over 4, and the degree right here cancels out with that degree. So 3 pi over 4 radians is equivalent to 135 degrees. Okay, so now pause this video and then try number 2 and number 3 on your own.
So negative 240 would be negative 240 pi over 180, which both of those are divisible by 60. So 4 pi over 3, which should be negative. So put a negative here. And then 75 should be 75 pi over 180. And both of those are divisible by 5. 15 pi over 36. And both of those are divisible by 3. 5 pi over 12. Or I could use a calculator here. 75 over 180 is 5/12. And then this table here, you just put 180 in for pi. Let's see if you do it the same way.
So the other way, what if you're given radians and we want to convert it to degrees? And if you don't see any unit, then assume that it's radian. So since we need to get rid of radian now is in the denominator, degrees on top. The conversion rate is 180 over pi. And when we reduce this fraction, the 2 becomes 1. 180 divided by 2 is 90. The pi will cancel with the pi. The unit radian will cancel with the radian. And then we will end up with 270 degrees over 1, or 270. So now pause this video, try the next two, see if you can convert it correctly.
So instead of multiplying by 180 over pi, a simpler thing is just to substitute 180 for pi. And since it's a math input box, if I just hit enter, then I get negative 12. And then 3 times 180. Let's see. Put this in parentheses here. 3 times 180. Divided by 8. And then just hit enter. 67.5 degrees. 21, I'm going to skip that. And then 22. In class, it was hard to illustrate this because my monitor is so small. It's a larger monitor here. So maybe we should start with the ones we know off the bat. So 2 pi radians is 360. So we're going to do that right there. And then pi radians is 180. So I'll do that one next. And then if I substitute 180 divided by 2 is 90. So that one goes there. 180 divided by 6 is 30. 180 divided by 3, 60. 180 divided by 4 is 45. Then I have these a little bit more complicated here. So 180 divided by 6 is 30 times 5 is 150. 180 divided by 3 is 60 times 2, 120. And then 180 divided by 9 is 20 times 16 is 320. So this is the way it should look when you're done here. And that's it for radians. The rest of the slides are about the tangent.